I love you. Biggest one I found. I don't know where. So that not everything makes it. Yeah, I've seen her shirt. Just a couple of administrative things. The key to sections 1.1 to 1.3 is on Island, so you can see what I would have written if I were doing the homework. So you go back now and actually just check your own. And if you were missing anything, make sure you go and get it filled in. And then just email me and I'll reopen your slot and you can resubmit when you get those fixed. The schedule for the next couple of weeks. We'll be going over the last couple of topics today and Tuesday on discrete dynamical systems. We'll start into game theory next Thursday and hear to test over discrete dynamical systems, not this weekend, but next weekend. And then we'll spend a week and a half on game theory, and then you'll have your test over the game theory stuff. So, the fundamentals of game theory are interesting and useful. After that, you start getting into much more precisely tuned stuff that's tuned towards certain types of economics or finance or specific types of games, and we won't get into that specialized part of game theory. We'll just look at the general foundation stuff.
When that was created with economics in mind?
Yes. That's why John Nash, a mathematician, got the Nobel Prize in Economics in '94, I think it was.
I just didn't know if he had economics in mind when he was doing something.
Yeah, well, according to the movie, I had something else in mind, but we won't go there.
What?
A Beautiful Mind.
Oh, I see.
So we won't say what might have been the original motivation for it, but
I wasn't sure if it was in his publication at all.
But in the publication, you're looking at human interactions. I mean, really, a game is just a human interaction, and so they were looking at economic interactions. You also look at just general interactions where, international affairs, things like that. But I'm pretty sure his original paper, although I've never read it, had economics in mind when he was doing it. So, any questions about schedule? And then you can correct your own on 1.1 through 1.3. Yes?
So, yes, we have 2 tests, 2 consecutive weekends.
Yep. Yeah, for right now. Then we'll head into graph theory. Graph theory we're going to spend much more time with because there's much more that's just foundational to graph theory that you should know about if you're going to progress as an applied math major. Graph theory is becoming a more and more important branch of mathematics, and so we'll spend more time there, plus it naturally moves into our very last segment, which is on simulations. Because as you do graph theory, you very quickly find out that you can't do it by hand. And so it's all about how do I get a computer to figure these things out for me.
On game theory, we have a project, yes, still? Even though it's a weekend?
Yeah, although it's, the scale of the projects will be different, and this one will be a fairly small one. There'll be a choice, but one of them will be just for you to create your own game or find your own game and do a little basic analysis of it. Others, yes?
I know the syllabus talks about some sort of like culminating project.
Mm-hmm.
When are we going to hear more about that, and when's that thing? I mean, it's just going to be due at the end of the semester, or what?
It is. It's just due at the end of the semester. You're basically going to write a professional journal article on some application that you're interested in. So you can be, right now you can be starting what topic you might be interested in doing and looking around for those. The specifics of exactly what you have to do, I'll be handing out at midterms here in the next week. So you can get started on to working on it. But you can be thinking about that. Now, we do have the project with the geology department that we're working on. And so, I think there's 2 of you that have had PDEs. I would like for you to work on it, because it's going to be a PDE model. And if you don't know what I'm talking about, that means that you're exempt. But
What if we didn't do super well in PDEs?
the mere fact that you know what a PDE is and what they look like, and that you've derived the heat equation, will be of immense help in this. So if you really don't want to, that's okay, you can beg off. But those, if you, I don't know, I've forgotten who the other person is that has PDEs. Okay.
I've worked in them. I wanted to work on it.
Well, you wanted to work on it, so you're fine. You can be on it, and you, if you're okay with being on it, and you know, like I say. Then we're going to be doing 2 groups on that. One group will be doing a PDEs model, which kind of doesn't require you to have seen PDEs, but it would be nice if you've seen PDEs. And then we'll have another group working on a simulation model for it. So if you have an interest in computer science and doing math on computers, and using computers to simulate something that's happening in real life, let me know, because that would be a project you would probably be interested in. That can be your semester project, to work on that. If you choose one of those 2 projects, it saves you the fact that you don't have to write a full, honest-to-goodness professional journal article on it, because we won't have finished it by the end of the semester. So all you'll have to do is basically write up your research notes on it. If you don't work on either of those 2, then you will have to go through write a full professional journal article on whatever subject topic you pick. And like I say, I'll be handing out the stuff that specifies exactly what it's going to look like here at midterms.
If we're doing a math project for another class, can we like go over it?
Yeah, sure. Yeah, that's fine.
For the PDEs model, are we going to be using like MATLAB
Mm-hmm.
or okay?
Eventually, we'll have to see how far we get this semester. The first thing we have to do is actually come up with a model.
Something that we want to model?
No, we have what we want to model, which is, you know, you're talking about the magma coming up and those basalts, and then the basalts melted and came up and then went up. What we're looking at is that process of the magma coming up, and as it comes up, it changes its chemical constituency, because as the pressure goes down, the temperature, the boiling point changes, and so you get different things precipitating out. And so the density changes, and so we're going to be looking at how all of that occurred, coming up with a model for that. The first model, though, hopefully we'd be able to finish this semester, would be one where you have the magma going up just a nice between 2 plates, but the plates are heated, and there's a heat gradient along the plates.
Oh.
And so you have your magma coming up in between 2 things that are heated, but the heat isn't even on the 2 plates. And how does heat dissipate and so forth in the magma as it rises through that dike?
Okay.
So that's the first thing that we'll be trying to come up with.
Are you going to start that again? Sorry.
Brother Moore, I talked to him again this week. He's still catching up on some field trip stuff with some other classes. It'll probably be next week that we would be getting together with his students, and then they would be meeting with those 2 groups and explaining the problem to you and talking about what needs to be done. So as soon as he's ready to go, but it sounded like it would be next week would be the earliest that he would be ready to talk to us about it. So, other questions?
Sorry. So you said that that was one of the projects. The other one was like computer modeling.
Yeah, the other one would be
Is it the same thing?
would be a computer simulation of the magma. Same problem, different approach to solving it. So instead of having to know PDEs, we would just be putting together a computer simulation where we would be sort of following the magma on the computer. The computer would actually flow the magma, and we would keep track of all the properties as it went.
What program would you use that when doing that?
Probably do MATLAB. Although, you know, we'd have to see. Depends on how you construct the thing, what the best tool would be. Worst case, we'd have to do it ourselves in C. Or at least do some segments.
That's a lot of fun.
Yeah. That's, you know, I mean, and we're not talking about getting that done this semester. What we would be doing is getting the initial phase of it done this semester. And then we'll hand it off to some students next semester. Anything else?
Yes.
They're right down here. Clayton, you want to pass those down? Okay, anything else?
I have a do you pick these up at some point, or are we supposed to bring them to you?
I need one per group. Presumably they'd have the same information, so yes, I do need one per group. Yeah. I think some of you handed those in already. If you have, fine. If not, I need to get those. The other thing is there will be a place on iLearn for you just to put your ratings of how effective the presentation was that you got. So watch out for that one. Okay. So we've been looking at, you can call them difference equations, you can call them discrete dynamical systems. There's a variety of names for them. Those are the two most popular. Recursive functions. So we've been taking a look at those. What we want to do today is walk through an example, and you essentially have the example in front of you. And so you don't need to be too worried about the details, because the details are on your sheet. What you want to be doing is watching and making sure that you understand the steps so that you can do it yourself. We're going to go back to the lake trout, where we finished last time. The model that we came up with for the lake trout last time turns out to be a very complicated model, very difficult to analyze. There is no way to solve it in terms of actually writing down a function for the lake trout and a function for the cutthroat that will tell you how those go with time. And so you can analyze it. There's a bunch of tools you can use to analyze it. We won't get into all of those tools because we don't have the time. You can take, there are entire books written on discrete dynamical systems. You can take year-long course sequences in discrete modeling. So obviously we're not going to be able to hit everything. But we've kind of given you a flavor of what goes on.